Vehicle Systems Overview. Hello folks, welcome to this comprehensive lecture on vehicle systems. Today, we will delve into the fundamental components of vehicles, including engines, transmissions, brakes, and more. By the end of this session, you will have a deeper understanding of each system's role, their components, functions, and basic diagnostic techniques. Let's begin by exploring these critical systems. Introduction to vehicle systems: engine, transmission, brakes, etc. Modern vehicles are complex machines composed of various interdependent systems that work in harmony to ensure optimal performance. At the heart of every vehicle lies the powertrain, primarily comprised of the engine and transmission. These systems, alongside others like brakes, contribute to the vehicle's functionality and safety. The engine. The engine is often referred to as the heart of the vehicle. It converts fuel into mechanical energy, which propels the vehicle forward. There are several types of engines, including internal combustion engines (ICE), electric motors, and hybrid systems (P). Internal combustion engines (ICE) utilize gasoline or diesel fuel. They operate on a cycle of intake, compression, power, and exhaust. Electric motors use electricity stored in batteries to generate motion. They offer high efficiency and are environmentally friendly. Hybrid systems combine ICE with electric motors to optimize fuel efficiency and reduce emissions. System components and functions. Cylinders house the pistons and are essential for combustion. Pistons move within cylinders, converting combustion energy into motion. Crankshaft converts pistons' linear motion into rotational motion. Camshaft controls the opening and closing of valves, coordinating with crankshaft movement. Fuel system delivers fuel to the engine in precise amounts for combustion. The transmission. The transmission is responsible for transferring power from the engine to the wheels. It adjusts torque and speed, allowing the vehicle to accelerate efficiently across different driving conditions. Manual transmission requires driver intervention to change gears using a clutch pedal and gear stick. Automatic transmission selects appropriate gears without driver input, enhancing convenience. Continuously variable transmission (CVT) offers a seamless range of gear ratios, optimizing fuel economy. Key components: gearbox houses the gears and synchronizes their operation. Clutch disconnects the engine from the gearbox in manual transmissions. Torque converter replaces the clutch in automatic transmissions, allowing power transfer at various speeds. The braking system. The braking system is crucial for vehicle safety, allowing controlled deceleration and stopping capabilities. Disc brakes use calipers to squeeze pairs of pads against a disc to slow down rotation. Drum brakes use shoes pressing outward against a rotating drum to achieve braking. Anti-lock braking system (ABS) prevents wheel lockup during sudden braking, maintaining steering control. Key components: brake pads, shoes create friction against rotors or drums to slow down the vehicle. Rotors, drums, rotating components that brake pads or shoes act upon. Brake lines transfer hydraulic fluid to apply pressure on brake components. Basic diagnostic techniques. Understanding basic diagnostic techniques is vital for identifying issues in vehicle systems. Here's how you can start diagnosing problems effectively. Visual inspection. Regularly check for leaks, wear, and damage in visible components. Fluid levels and quality. Ensure fluids such as oil, coolant, and brake fluid are at appropriate levels and are clean. Listen for unusual noises. Unusual sounds may indicate issues within the engine, transmission, or brakes. Check engine light. A warning light on the dashboard indicates potential issues. Use an OBD scanner to diagnose specific problems. Test drive. Assess vehicle performance, noting changes in handling, acceleration, and braking. Executive summary. Here's a summary of vehicle systems overview. Engine system. 1. Engine types: gasoline, diesel, hybrid, electric. 2. Engine components: cylinders, pistons, crankshaft, camshaft. 3. Engine functions: air intake, fuel injection, ignition, exhaust. 2. Transmission system. 1. Transmission types: manual, automatic, continuously variable CVT. 2. Transmission components: gears, clutches, torque converters. 3. Transmission functions: gear shifting, torque multiplication, speed reduction. 3. Braking system. 1. Braking types: disc brakes, drum brakes, regenerative braking. 2. Braking components: brake pads, rotors, calipers, master cylinder. 3. Braking functions: speed reduction, stopping, stability control. 4. Suspension and steering system. 1. Suspension types: independent, dependent, semi-independent. 2. Suspension components: springs, shock absorbers, struts, control arms. 3. Steering components: steering column, steering gear, linkages, wheels. 4. Suspension and steering functions: ride comfort, handling, stability. V. Electrical system. 1. Electrical system components: battery, alternator, starter, wiring. 2. Electrical system functions: power generation, power storage, power distribution. VI. Cooling system. 1. Cooling system components: radiator, water pump, hoses, thermostat. 2. Cooling system functions: engine temperature regulation, heat dissipation. 7. Exhaust system. 1. Exhaust system components: exhaust manifold, catalytic converter, muffler. 2. Exhaust system functions: emission control, noise reduction, exhaust gas removal. Here's a summary of vehicle system components and functions. Engine system. 1. Components: cylinders, pistons, crankshaft, camshaft, valves. 2. Functions: air intake, fuel injection, ignition, combustion, exhaust, transmission system. 1. Components: gears, clutches, torque converters, gearbox. 2. Functions: gear shifting, torque multiplication, speed reduction, power transmission, braking system. 1. Components: brake pads, rotors, calipers, master cylinder, ABS module. 2. Functions: speed reduction, stopping, stability control, anti-lock braking, suspension and steering system. 1. Components: springs, shock absorbers, struts, control arms, steering column, steering gear. 2. Functions: ride comfort, handling, stability, steering control, electrical system. 1. Components: battery, alternator, starter, wiring, fuses, circuit breakers. 2. Functions: power generation, power storage, power distribution, electrical system control, cooling system. 1. Components: radiator, water pump, hoses, thermostat, coolant. 2. Functions: engine temperature regulation, heat dissipation, cooling, exhaust system. 1. Components: exhaust manifold, catalytic converter, muffler, tailpipe. 2. Functions: emission control, noise reduction, exhaust gas removal, fuel system. 1. Components: fuel tank, fuel pump, fuel filter, fuel injectors. 2. Functions: fuel storage, fuel delivery, fuel metering, fuel injection, safety and security systems. 1. Components: airbags, anti-lock braking system ABS, electronic stability control ESC, immobilizer. 2. Functions: occupant protection, crash avoidance, theft prevention. Here's a summary of basic diagnostic techniques in vehicles. Visual inspection. 1. Exterior. Check for signs of damage, wear, or leaks. 2. Interior. Check for warning lights, unusual odors, or sounds. 3. Engine compartment. Check for leaks, worn belts, or damaged components. Diagnostic tools. 1. Multimeter. Measures voltage, current, and resistance. 2. Scan tool. Retrieves trouble codes and monitors vehicle systems. 3. Air pressure test kit. Tests fuel system pressure and leaks. Troubleshooting steps. 1. Gather information. Collect data from the vehicle's onboard computer and owner's observations. 2. Identify symptoms. Determine the problem's symptoms and possible causes. 3. Test and verify. Use diagnostic tools to test and verify the suspected cause. 4. Repair and validate. Perform the necessary repairs and validate the fix. Common diagnostic tests. 1. Compression test. Checks engine cylinder compression. 2. Leak down test. Checks for engine cylinder leaks. 3. Fuel system pressure test. Checks fuel system pressure and leaks. 4. Electrical system test. Checks electrical system voltage, current, and resistance. Best practices. 1. Always follow safety procedures, wear protective gear, and ensure a safe working environment. 2. Use proper diagnostic tools. Use the correct tools for the job to avoid damaging the vehicle or causing injury. 3. Keep accurate records. Document all diagnostic tests, repairs, and maintenance performed on the vehicle. In conclusion, understanding vehicle systems, their components, and basic diagnostic techniques empowers you to maintain your vehicle effectively and identify issues promptly. As you become more familiar with these systems, you'll develop the skills needed to ensure a safe and efficient driving experience. Thank you for attending today's session. We hope this lesson has enriched your knowledge of vehicle systems and inspired a deeper appreciation for the intricacies of modern automotive engineering. See you in the next lesson. Happy learning, folks!